All right, chapter 7, we're going to be doing, looking at ratios and proportions. First, 5.1, we're going to do ratios. 5.2, we'll do proportions. Ratios are just a comparison between two things. Like when we compare in our classroom, we have so many girls to boys, and it was a 1-to-1 ratio. We had 9 boys and 9 girls, which would make it 1-to-1. But now we have 9 girls to 8 boys. So we have a different ratio in our classroom than we had before. It's not very hard. Okay, so we got girls on the top and we have 8 boys on the bottom. I can't actually reduce this because it doesn't reduce. It wouldn't matter which way we put it. We could invert it and say we have 8 boys to 9 girls. The important thing is here, when you're reading your questions, that you remember and you recognize that whatever the question in the book says is first, that is the number that goes on top. So if I were to say the ratio of, this is the ratio, this one right here, above this ratio of girls to boys. Girls is on top. This one over here is the ratio of boys to girls, because girls is on the bottom. And I could write this out as 8 to 9, and for this one it could be 9 with the colon and 8. This is another way of writing the ratio. But don't get too worried about that. Everything's going to be in fractions, fortunately. So example 1 here is setting up the whole foundation for this whole thing here. Part A, it says find the ratio of males to females. Remember, I already said this is important. The males has to be on top, and you can see if you look on page 164 that they have actually done that. They've actually put the males on the top and females are on the bottom, because that's the way they decided they wanted to do this ratio. So it says there are 45 males and 60 females in the subway car. The subway car travels 2.5 miles in 5 minutes. So it's going to ask us about miles a minute too. But so far, what do we have? We have 45 to 60 females. There we go. So that's our ratio. And then we would reduce it. And the easiest way to reduce it is what we've learned so far. We just did yesterday. We're going to divide the top and the bottom by a number. They don't show you that, but that number here happens to be 15. 15 goes into 45. 15 also goes into 60. 15 goes into 60 4 times because, 4 times because 15 plus 15 is 30. And 30 plus 30 is 60. That's the way I look at it anyways. Whatever works for you. And then 15, since 15 and 15 is 30, that's 2. Then one more is 45, that's 3. So the ratio of males to females is 3 to 4, or 3/4. So it makes it an easier number to work with. Now, if we're going to find the speed of the subway car, if it's traveling 2.5 miles in 5 minutes, we have miles to a minute first is what we have. So we have 2.5 miles to 5 minutes, which is going to equal, they're going to turn it into, why do they multiply by 5? Let's see, what are they doing? They're multiplying by 5 because the speed is 0.5 miles per minute. Oh, I see. They're trying to reduce it down, so that's the reducing thing again. Okay, so here we go. Let me get my eraser here real quick. I don't like this. So they divided, and they divided, and they divided by 5 and 5, and they got a nice number here. 5 into 5 is 1. This one's easy, right? Because we know that one's 1. This one's a little harder if you're not comfortable with your math. If you're not, look at it without the decimal. 5 goes into 25 how many times? 5 times 5 is 25, right? If 5 times 5 is 25, to make it 2.5, 5 times 0.5 would equal 2.5, because 5 times 5 is 25, and then I would move the decimal over 1 time because of my decimal being there. So that's how they get this answer for that. So we've got the two things here. The speed is 0.5 miles per minute. So there we go. That's example 1. Example 2. Let's make it faster now. Example 2. So far they haven't shown us anything really spectacular or super complex. It's all pretty easy. We're finding the rate for a ratio table. Oh, okay, because it's a little bit like a function table. This makes sense. All right, so if you can see what they've done here, they're just showing us the pattern. The first ratio is, they flipped it upside down on us. I don't know why they did that, but they did. Doesn't really matter which is on top or the bottom, except for they're going to ask for a particular thing. It says it shows the cost. Find the unit rate in dollars per square foot. So that's why they flipped it. They wanted dollars. That looks like dollars. Let's do this again. Dollars per square foot. And so that means dollars is on top and the square feet are on the bottom. That's why they have 100 over 25. Have to do it in the same ratio that they did it. All right, dollars, and this is how you represent feet squared. All right, so to reduce that, I'm going to use, what would you use? I would use a 25, because 25 goes into the bottom number equally. And so when I equalize it out, I've got 4 on the top and 1 on the bottom, which means it is $4 per square foot. Or I could do the foot squared sign. Oh, that was not very good. Do that again. Per foot squared. There you go. And that would be the answer, simplified. Yeah, so the rate is $4 per square foot. There we go. And example number 3 is just not very much more exciting, except for we're dealing with fractions and we're going to do some graphing. So that makes it look more complicated, but it's not. It is just a little more stuff to do, that's all. So example 3. And now I'm on page 165. 165. Okay, it says choose. Well, we're going to read it. It says the graph shows the speed of a subway car. Find the speed in miles per minute. Compare the speed to the speed of the subway car in example 1. All right. I don't know, have you ever read a subway car? Do you know how fast it goes? Have you thought about that? Or how much it costs to ride one? So this graph is to help figure those things out. All right, so the first thing it says, choose and interpret a point on the line. And they've got 2 points already chosen for us, which make it easy. We have a point 1/2 by 1/4. Remember, this is a ordered pair. The first one is your x. The second one is your y coordinate. When you look at a coordinate plane, you've got your y, which is up and down, and you have your x, which is right to left. So your x is this one. That's the first coordinate you read, and then the y is this one, the one that goes up and down. So when you look at that one, the first coordinate, 1/2 and 1/4, that's about where it sits. 1/2 over x and 1/4 up for the y. That's where they got their coordinate. Indicates the subway car travels 1/4 of a mile in 1 minute. You can see that they've got the graph is labeled that way as well. The difference for their graph is they do not have this thing coming out this way. They just have this part right there. So all their data goes this way because they don't, we're not interested in the negatives. That means it would be going backwards. So the next point on it is 3. So if we were to mark over 3, 1, 2, 3, that would be where this one is. And then maybe it's not as exact as it could be, but something like that. 3 times, and it's 1.5. Oh, I'm a little bit low, but it should be somewhere up here for that. Anyway, so the next coordinate is 3 for the x, and 1 and 1/2 for the y. That's all it is. Pretty simple. So then what we're going to do is we're going to figure out the distance traveled by the time lapsed. So we have distance over time to figure this out. So just going to write that down. Distance over time. Funky T's. Okay, here we go. And on the first coordinate, it's 1/4 over. Look at this. This is kind of confusing when you have a fraction over a fraction, isn't it? I remember when I saw that the first time. I was like, ew, help. Anyways, it's not hard. Because really, all we're looking at here is this is 1/4 divided by 1/2. And if I write it down, 1/4 dividing 1/2. This is information that we would have covered in 6th grade. I just covered it with 6th grade this year, actually. One way to do it is you multiply, cross multiply, or whatever works for you. The way they showed it here, we rewrote the quotient, which is this right here. They flipped it over. You can invert and multiply, because what you're going to do, either way, you've got to multiply this times this. That number goes on top. You multiply this times this, and that number is going to go on the bottom. So if I invert and multiply, and I rewrite it, it's going to be a multiply. I'm going to do the dot because that's what we use for multiplication now. Equals, straight across, 2 times 1 is 2. 4 times 1 is 4. I've got the same thing up here. I went up, this is 4. The 1 going down to the 2, back up. 1 times 2 is 2/4. So you see we've got the same problem, same answer both ways. Then when I reduce it, it's going to come out to 1/2 because I'm going to divide this by 2, and I'm going to divide this by 2, and I'm going to get 1/2. So the speed of the subway car is 1/2 mile, because distance is measured in miles here. If you look at the chart again on page 165, and the time is measured in minutes. So it travels 1/2 mile in 1. Bad writing again. Listen to Mr. McCombs laugh. Ha ha ha. All right, so 1/2 mile, and I'm just going to do per minute is a easiest way for me to write it here instead of the other thing I was trying to write. Minute. Minute. I'm really doing bad here today with my writing. I know why. I'm getting tired. Minute. A minute minute. There you go. That's it for example 3. Let's see how much more I want to do for you here. Oh, there's an example 4. So I guess I'm going to do that one too. We are solving a ratio problem. Looks like we've got a couple things here. We mix a 1/2 cup of yellow paint for every 3/4 cup of blue paint. I'm on page 166. Oh, I'm all out of yellow paper. How's that? I'm going to go up here. There we go. And we have example 4. Alright. To make 15 cups of green paint, how much yellow paint and blue paint do you use? You mix 1/2 a cup of yellow paint for every 3/4 cup of blue paint. So we need to figure out how much we need to do so that we get a total of 15 cups. This would be how you use a recipe too, and change a recipe so you have a certain amount. Anyways, all right. So we have the method 1. Oh, well, there's 2 methods. Look at that. We have method 1. It has a ratio. take a picture. All right. Okay, the ratio of metal we have, I'm just going to show you what we got here. We're paying attention to this. We've got yellow paint to blue paint. That means the yellow paint goes on the top of the blue paint when you're doing the fractions. It looks like, let's see, how are they doing this? This is an interesting way of doing it. If I double this time, or I quadruple it, I get 2 and I get 3 of this one. Now that kind of makes sense because this here is the same as 2/4, right? And if I multiply it by 4 times, I would have 4 times 2 is 8, and 8 over, anyways, it comes out 8 over 4 equals 2. And 4 times 3 would give me this, 4 times 3 would give me 12, and 12 over 4 is, well, obviously 3, because 3 times 4 is 12, so 12 divided by 4 is going to equal 3. And they multiply it one more time to give us this 6 times 3, and 9, and then that gets us up to 15, because I see what they did here. This is pretty genius. They figured out that they needed 5 cups. Right here, if you add a half a cup plus, or 3/4 of a cup plus a half a cup, that gives you a total of 5/4. So when they multiply times 4, that's going to give them 5, because 4 times 5 is 20, and 20 divided by 4 is going to equal, it's going to equal 5. Oh shoot, just erase some of this stuff. Here we go. So this is one way to get to it. This is probably the easiest mathematical way to get to it because you don't have to think about the ratios quite as much. You are just focusing on just adding the things up, which to most people, addition is the simplest way of getting to something. So I'll just point it out one more time. They've multiplied by 4. 4 times 1 is 4. 4 divided by 2 is 2. 4 times 3 is 6. No, 4 times 3 is 12. And 12 divided by 4, put you back at 3. 2 cups plus 3 cups equals 5 cups. They want to get to 15 cups, so they multiplied by 3, and they got 15. When they multiplied by 3, they had to multiply everything by 3 so you could figure out what you needed. They had to have 3 times 3 is 9. 3 times 2 is 6. And that way they had a total amount. They used 6 cups of yellow, 6 cups of blue. They had a total of 15 cups. So example number 2, or method number 2 is, I suppose, a little different. They're going to use the fraction of green paint that is made from yellow paint and the fraction of green paint that is made from blue paint. If you use 1/2 cup of yellow paint for every 3/4 cups of blue, the fraction of the green paint to the yellow paint is, remember, it's fraction of yellow to green. Oh, I see what they did. This is cool. The yellow paint is 1/2, and then you get a total of both of them together. And then the total of the blue, or the fraction for the blue, is this over the total number, or total amount of paint. So when they added this together, they got that. If you notice up here, when they added the two together, you have 5/4. You wouldn't have, we fix it once, you'd have it done. Love hot rods. Okay, love hot rods. Somebody's hot rodding around the house. Okay. Back on task. Here we go. Yellow, we have 1/2 to 5/4. That's the total amount made when you make remember when we want the total together. This is maybe more confusing, but it's good to know it. We're using the fraction of green paint. And the amount of green paint is the amount that you put of blue and yellow together. That's 5/4. And then the fraction of yellow and the fraction of blue that you put in to get that color. Now, what we're going to do is we're going to look at what the next step is. So their total ratio, they went out and, oh yeah, that's nice. See how they did it all for us. This is a lot more math than the other one maybe. But when they took this here, 1/2, and they inverted and multiplied. See how the 4 is on the bottom here? They took it over and they inverted it and multiplied it. I'll show you real quick what they did. So we have the 5/4. So I'm going to just bring that over. We have 1/2 divided by 5/4. And if we were to write it another way, it's 1/2 divided by 5/4 equals, and then we're going to turn this upside down because I'm going to have to multiply both ways, or I can just do this. 1 times 4 is 4. Make sure I get the right numbers in. 1 times 4 is 4, and 2 times 5 is 10. And all they did over here is they just flipped it over, so they didn't have to mess with that. Is they have the same thing. 1 times 4 is 2, and 2 times 5 is 10. But they reduced it before they even did it. So I have 4 over 10, but if I reduce it with a 2, I get 2/5 as well. So it doesn't matter which way you do it. They just are trying to simplify it maybe too fast and could have lost somebody along the way. So similarly, the fraction for the green paint is made from the blue paint, and they did the same thing here. They've got these 3/4 on top. So that's that 3/4 divided by, I'm going to skip this part here because this means it's divided by 5/4. I'm going to cross multiply. 3 times 4 is 12. 4 times 5 is 20. And what do I have here? I've got, it reduces with 4. Because there's going to be 3. 4 goes into 12 3 times. 4 goes into 20 5 times. So there we go. We got the same answer as they got. So we're doing our math right. So if you use 2/5, 2 times 5 times 15 equals 6 cups of yellow paint, and 3/5 of 15 equals 9 cups of blue paint. Yeah, there you go. Just showing you how to do it a different way. They're just using the percentage thing. What they're showing us right here, if you're not catching it, is a multiplication. 2 times 15 is the same as saying 15 over 1. We don't need to worry about common denominators, but if I go straight across, first thing I'm going to do is I'm going to cancel this out. Okay, so I'm going to cancel this out. I'll do it both ways. 5, I can take 5 out of here, and if I take 5 out of here, I would take 5 out of this 3 times. I can only take 5 out of here once, so it'd be 2 over 1, and then this would become 3, right? So this would be 3 over 1. And when there's 1s on the bottom, 1 times 1 is 1, and when you divide by 1, it remains the same, right? So that just helps us remember that we're doing fractions. So I take this out here, I have 3, and I have a 1 here, and 2 times 3 is 6. So here it shows us our answer right here.